In this video, we're going to go over differentiation by first principles. So, this question is 3 marks, so it should be fairly simple. Prove from first principles that the derivative of 6x is 6. So, the first thing that we can do is we can set f of x is equal to 6x. And we can now use our formula that we have for differentiation by first principles, which is f prime of x is equal to the limit of, as h tends to 0, f of x plus h minus f of x all over h. So limit can be shortened down to lim when we are writing it in our working out. So f prime of x, now if we substitute our 6x value, we get limit, so lim as h tends to 0. So here on the outside we're going to have our 6 because our x plus h is substituted as our x value here. So 6 times x plus h minus, so f of x is just 6x, all over h. And so this is equal to lim, as h tends to 0, 6x, which is 6 multiplied by x in the brackets, plus 6h minus 6x all over h. Now simplifying this down, we can cancel out our 6x's. So we're left with this equal to lim, as h tends to 0, 6h over h. And now we can divide h out of the equation. So we can cancel out our h's, and we're left with f prime of x is equal to lim of, as h tends to 0, 6. Now, from this, there is no value of h. So since there's no value of h, we don't have to substitute 0 into our equation here. So f prime of x is equal to 6. And we have proven from first principles that the derivative of 6x is 6. Now, we'll go on to our next question. Proof from first principles that the derivative of 4x squared is 8x. So we're going to start off with setting f of x is equal to 4x squared. And so using our equation for to do differentiations by first principles, f prime of x is equal to lim, as h tends to 0, f of x plus h minus f of x all over h. So we'll now substitute our value of 4x squared in as our function. So as lim of h tends to 0, 4 times x plus h the whole squared minus 4x squared. So the values in our functions just get substituted in. And this is all over h. So we can expand our brackets here binomially. So we get lim, as h tends to 0, 4 times x squared plus 2xh plus h squared minus 4x squared all over h. Now we can multiply our 4 into our brackets. So we get lim as h tends to 0, 4x squared plus 8xh plus 4h squared minus 4x squared all over h. And we can cancel out our 4x squareds here. So we're left with this equals to lim as h tends to 0, 8xh plus 4h squared all over h. And now, if we cancel out our h's, we're left with f prime of x is equal to lim as h tends to 0, 8x plus 4h. Now, for structure and clarity, we will write as h tends to 0, and then we can write f prime of x is equal to 8x plus 4, and we can substitute 0 in for our h value for h, and this simplifies down to f prime of x is equal to 8x, because 4 times 0 is 0. And we have proven by first principles that the derivative of 4x squared is 8x. Now, instead of having numbers, we're going to have letters here. F of z is equal to a times z squared. A is a constant. Prove from first principles that f prime of z is equal to 2az. So f of z we know is equal to az squared. This is given in the question, and we can now use our equation for first principles. So we have f prime of x is equal to lim as h tends to 0, f of x plus h minus f of x all over h. And so now we can substitute our values in. So we know that we have f prime of z is equal to lim as h tends to 0. Now we'll substitute our values of z plus h and z. So this would be a times z plus h squared minus a times z squared all over h. Now we'll expand our brackets. So for this we get lim h tends to 0, a times z squared plus 2zh plus h squared minus az squared all over h. And now we can multiply our a into the brackets. So for this we get this equals lim as h tends to 0, a z squared plus 2azh plus ah squared minus az squared all over h. Now we cancel out our az squareds. And with this, we're left with this equal to lim as h tends to 0, 2azh plus ah squared all over h. And now we can cancel out our h's. So we get 2az So lim h tends to 0, 2az plus ah. Now, as h tends to 0, we can now substitute it in as f prime of z is equal to 2az plus a, and we can substitute 0 for h, and this is equal to 2a f prime of x is equal to 2az, as a times 0 is 0, and we have proven from first principles that the derivative of az squared is equal to 2az. As always, thank you for watching, and make sure you subscribe so you don't miss out on any new content.